Hi, and welcome to this second video in a series of data presentation. In the last video we looked at central tendency, by which we mean averages. In this one we're going to be looking at measures of location and spread. So what we're going to be doing in this one is looking at measure of variation, so we're talking about interquartile range and percentiles, and look at a technique called linear interpolation. So when looking at a data set, we might look at averages as a way to be able to understand what's going on with potentially two groups of data, but unfortunately that averages on their own, or central tendency on their own, don't tell the full story, as we're going to see in this example here. So what we've got is two classes that took the same maths test, and what we've got there is their percentage scores below class A and class B. If we just look at their averages, let's do the averages. So we'll go the mean for class A, 60%, and the mean for class B, also 60%. If we look at median, again the median for class A is 60%, it's right in between those two values there, and the median for class B is also 60%. There it is, it's that figure there. So if we look at just central tendency, we might say, well, you know what, those classes are exactly the same. But are they really? Well, just by briefly looking at the numbers, you can see there's definitely a difference between two classes. But we're not going to see that just from looking at the averages. We've got to look at some measure of spread. And if we just take the very simplest one, let's have a look at the range, which you should be familiar with, which is just the largest value, take away the smallest value, measure just how spread out the data set is. And now if we look at class A, it's got a range of 49%, whereas for class B, it's got a range of 16%. So there's definitely a difference between those two. And so what can we say based on these two figures here? Well, we can clearly say that class A is a much wider range of mathematical ability compared to class B. And let's say the whole point of that side is that you're just not going to get that just by looking at these figures up here. It's vital that we also look at a measure of how spread out the data is as well. Now, range, to be fair, is very, very simplistic, because what it really does is only just measures the difference between only two pieces of data, the biggest and the smallest. If, for example, you had a data set with maybe 200 pieces of data, you'd be ignoring the middle 198 pieces and just still be looking at two pieces of data. So we need something a little bit better than that. And an improvement on the range is to look at the interquartile range, which again is something you should be familiar with from GCSE. And what the interquartile range does is measures how spread out the middle 50% of the data is. So in that case, it kind of ignores the outliers. It gives us a slightly better representation. So we've got a little bit of notation coming in here. So we've got our minimum value, maximum value. I'm going to refer to these as Q0 and Q4. The median is the middle value. I'm going to call that Q2. And therefore that means that the lower quartile, 25% of the way through the data, I'm calling that one Q1. And corresponding the upper quartile is clearly going to be Q3. And the quartiles, what they do is split the data set into four equally spaced groups. So there's 25% of the data in here, 25% of the data in here, 25% there, 25% there. And here's our interquartile range, the difference between the lower quartile and the upper quartile, and that's the middle 50% of the data. In addition to the quartiles, it's often useful to calculate what's referred to as percentiles. So, for example, if we wanted this thing, we're going to call it P95, that's the 95th percentile, 95% of the way through the data set. So we might say, okay, there's a value here such that only 5% of the data is above it. And we can calculate differences for those. For example, if I had the P95 and also P5, then we can say that 90% of the data would be in between those two things. Right, so we've mentioned them. Let's have a look at how we go about doing some calculations. Let's start off with media and interquartile range. So what I've got here is some values taken from the large data set, which is to do with air pressure in October in Beijing. And I've already got the data in order. We've got 17 pieces of data, and so we're going to calculate the median. And so first we need to do is figure out where the median is. And again, we've seen this before. We just go 17 plus 1 divided by 2. It's the 9th piece of data. So we just need to count through 9 pieces of data. There it is. So the median is 1010. Right. Now, if we're going to be going for the lower quartile and upper quartile to be able to calculate the interquartile range, I'm now looking at the data here. I've got 8 pieces of data there. And so the middle of those pieces of data is going to be in between the 4th and the 5th piece of data. So what we've got there is halfway between those. So Q1 our lower quartile is 1004.5, and if we apply exactly the same thing on the data up here, we need to go in between the bits of data, so we're going to be going there. So Q3 1013, so therefore that gives us the interquartile range is 8.5. Right, moving on, let's have a look at group data. Now, when using group data in class numbers, we don't know the exact values, so that means we have to do a bit of estimating, and when we're looking at means, we've seen previously that we use midpoints for those. When we're doing medians, quartiles and percentages, we're going to use something called linear interpolation. And what we're doing by doing this, we're going to make an assumption that the data is evenly distributed throughout that particular group. Essentially, linear interpolation says, well, okay, if we're going to assume that the median is a certain proportion of the way into a particular group, so I've used an example of, let's say, the median we know is 3/5 of the way into a particular class, then we know our median value is 3/5 of the way in between the upper and the lower class boundaries. And that's going to make more sense when we have a look at an example, and I've got a diagram to explain what's going on. So here we go then. We've got the length of time that students are spending on their homework in the evening, and we want to find the lower quartile and the 90th percentile. Now, before we do any calculating, the first thing we've got to think very carefully about is the boundaries of the groups. Because what we've got here is the time is rounded to the nearest minute. And you'll see in the way these groups have been set up, we've got gaps here. So kind of this group goes to 34, this group goes to 30 from 35. So there's a gap in between 34 and 35. So what happens, for example, if the student spent 34.5 minutes on their homework? How are we going to, which group is that going to go in? Well, what we're doing is saying, well, if it's been rounded to the nearest minute, we're saying that that means that anybody that does over 29.5 minutes of homework is going to come into this group. And anybody that does anywhere between 34 and 34.5 minutes is also going to come into this group. So the boundaries are not actually at 34 and 35. The boundary here is going to be at 34.5. So that has an impact on what we're going to be doing to find quartiles and percentages. And it's absolutely vital that when you're working with data that's been grouped like this, you consider very carefully what your class boundaries are. The other thing to note is that previously with discrete data, we said, well, kind of to find the middle value. For example, I'm looking at this one here. We did n plus 1 over 2. Now for group data, we're just adjusting that definition slightly. So it's just n divided by 2. The lower quartile, rather than being n plus 1, would just be n divided by 4. Upper quartile, 3/4 of n. Okay, so the definitions of how we find exactly where these groups are change slightly for group data. Right, now we've got all that done out of the way, let's have a little look at what we're going to do. We need to find the lower quartile. So first of all, we need to decide whereabouts the lower quartile is. We've got 30 pieces of data, so it's going to be the 7.5 value. And that's going to put it into this category here. So let's just have a little look at what's going on with this group. So what we've got is a lower boundary at 34.5, an upper boundary at 39.5, and somewhere within there is our value Q1. And we get the sense that if it's the 7.5 value, we know it's going to be somewhere down the lower end of this boundary. Right, now let's just have a little look at what's going on with the data. So we know that what we've got is 5 pieces of data in this group. So the boundary is starting at 5 here. 12 bits of data in it in total, so it's going up to 70. So the data that we've got in here goes from the 5th piece of data up to the 17th piece of data. Now, what that means is that 7.5 is there, and now we can start saying, okay, if Q1 is this far into the range, we just need to kind of calculate what proportion this distance is, compared to these values here. And we do that by saying, well, okay, Q1 is that far into the category, into the class boundary. So we're talking about that distance there, divided by the entire width of the boundary. And that's going to be the same as how far it is into the group. So again, we've got on the least load values there, that distance there, divided by how far it is into that entire distance there. So these two things, these distances, are going to be the same. So we can put them equal to each other. Now we've got that, we've got a simple equation. We've just got Q1 to find. Particularly these bits on the bottom of the fraction are just a single number, simple subtraction. So it won't take a massive amount of working out and rearranging to get to the fact that gives us Q1 is 35.54 minutes. We're going to do exactly the same when we're looking at P90 or the 90th percentile. So it's 90% of the way into the data, so 90% of 30, so we're looking for the 27th value, which is going to put it into this category here. And now let's do exactly the same as we did before. I always draw this little diagram, it helps me get my head around what's going on. So I've got my class boundaries on the top and P90, and then underneath the data, how many pieces of data we've got. So there's the 17th piece of data, we've got 5 plus 12, so that boundary starts at 17, and it finishes at 28. So, exactly the same calculation again, so we've got the distance here, divided by the total distance, and that's going to be the same as the distance here, divided by the total distance. And so that gives us that calculation there. So I'll just put that kind of, the top one is my first fraction, and using the same calculation using the bottom figures, that's my second fraction. And again, do the calculating, that gives me the 90th percentile is at 44.05 minutes. So that's basically telling us that 9% of the students did less than approximately 44 minutes, alternatively 10% of the students studied for more than 44 minutes.